Hi everyone. In this video, we are going to solve a problem related to back EMF of DC motor. So the problem is a 4-pole DC motor has lap connected winding. The flux per pole is 30 milliweber. The number of armature connector is 250. When connected to 230 volt DC supply, it draws an armature current of 40 amps. Calculate the back EMF and the speed with which motor is running. Assume armature resistance is 0.6 ohm. So, let me first write the given expressions or given values. So, given values are a 4-pole DC motor. So, number of pole is equal to 4 here, right? Has lap connected. So if it is lap connected, A is equal to number of parallel path equal to number of poles always, right? So here number of poles equal to 4. So A is equal to P is equal to 4. So both will be same here. Next, the flux per pole is 30 milliweber. So phi is equal to 30 into 10 to the power minus 3, 30 milliweber, right? Weber. Next, the number of armature connector is 250. Z conductor, armature connector will be represented by Z. So Z is equal to 250 conductors. Next, when connected to 230 volt DC supply, so the input voltage V is equal to 230 volt. This is input voltage, so we need to write it as V, right? If it is Vt, then it is terminal voltage. Terminal voltage means the voltage across the load, but here this is input voltage, so we are representing it as V, right? So 230 volt supply draws an armature current of 40 amps. So I suffix A is equal to 40 amps. Next, calculate the back EMF and speed. So to find, we need to find EB, value of EB, back EMF and speed N, right? These two are the parameters that we need to find. There is one more input parameter given in the question. Assume armature resistance is 0.6 ohm. So armature resistance RA they are given as 0.6 ohm, right? So we all let's solve this. So to find the value of back EMF and the speed, first let me find the value for back EMF. Through that, which can I find? I can find speed, right? So the voltage equation of DC motor, V is equal to EB plus IA into RA. From this I can calculate EB directly, right? So V is given here, input voltage, and IA is given, RA is given. I need to find the value of EB, right? So V is equal to R 230 is equal to EB plus the value of IA is 40 and the value of RA is 0.6. 40 into 0.6. So I will get EB is equal to 230 minus 40 into 0.6. I am bringing this term to this side, right side term to left side. So this minus sign here. So EB is equal to, when I manipulating this, I will get EB is equal to 206 volt. This is the back EMF produced due to the input voltage or input supply 230 volt, right? So if I give 230 volt, the motor generates an opposite EMF or induced EMF, and its magnitude is, which is man today is 206 volt, right? So I have found out the value of EB. Now I need to find the value of N. So I can find this with the help of back EMF formula. So back EMF is given by EB, right? So this can be written as EB is equal to 5P NZ divided by 60A, right? So I am expressing this EB here. So I have followed the value for EB here. So 206 is equal to the unknown expression in this term is, I know the value of EB, phi, number of poles, Z, A, everything I know, but I don't know the value of N. So from this I can calculate the value of speed N, right? So 206 is equal to phi. The value of phi is 30 into 10 to the power minus 3 into number of poles is 4 here, and I don't know the value of speed, and Z is equal to 250, the whole divided by 60 into, so number of poles equal to number of parallel path in lap winding, so A is equal to 4. So when I solve this, I will get N, right? N is equal to 1648 RPM, revolution per minute. This is the value of N, speed, right? So for the given question, I have found the value of back EMF and speed. Thank you.